Hello everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 6A. Myself Adesh Bazare, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the International Conference on Machine and Computing Technologies for Sustainable Development, MCT4SD 2025, Manila, Philippines. The conference is being organized in a hybrid mode. The physical event was held on 11 December in Manila, Philippines, and the virtual event is being held through Zoom on 12th and 13th December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Now, just before we start the session, I would like to introduce you all to the chair for this session, Dr. Jocelyn Sagondivera. Ma'am is an associate professor at Pangasinan State University, Philippines, with expertise spanning natural sciences, professional education, gender and development, and food and agriculture. A dedicated researcher and extensionist, she focuses on advancing knowledge and community development through her work in education, scientific studies, and gender responsive initiatives. Ma'am, I request you to please share your opening remarks with our authors.
Yes, hello. Am I audible now?
Yes, ma'am, you're audible.
Yes, a pleasant afternoon to each and everyone, especially to our presenters. Well, upon reading your papers last night, I would say that I am quite interested with your topic. They are all very interesting, and I hope this is not the first time that we'll meet, but we'll be having a collaboration in the future. In advance, I would like to say congratulations and of course to the organizer, to the MCT4SD. Thank you so much for inviting me as your speaker or session chair for this afternoon.
Thank you, ma'am.
Yes.
We also have with us Dr. Varsha Jadhav. Ma'am is an assistant professor in the Department of Artificial Intelligence and Data Science at Vishwakarma Institute of Technology, Pune, with over 19 years of teaching experience. She is also a member of the Board of Studies for the department. Her areas of interest include machine learning, artificial intelligence, data science, data structures, and design and analysis of algorithms. Ma'am, I request you to please share your opening remarks with our authors.
Yes, thank you, Adesh. Okay, I think I'm audible.
Yes,
Yes.
ma'am, you're audible.
Good morning, everyone. And I would like to congratulate GR Foundation for organizing such a flagship event. Every in a year, there are more than uh, 4 to 6 events being taking place of GR Foundation. This time I am online session chair, but yes, once in a year I also attended as physically session chair in Pune whenever it is organized. So I'm really very thankful for GR Foundation for inviting me as a session chair every time. And every time my experience is that I come across some new problem statements which I actually share it with my students so that we can work on it. And also this flagship event is a very glamorous event, I would like to say. I thank Dr. Amit Joshi and all the associates with GR Foundation. Thank you very much and all the best for your presentations.
Thank you, ma'am.
Thank you, ma'am. Now, I would like to start with the papers. The first paper to be presented is an optimized model for heart attack prediction using SMOD, Swiss and mini batch gradient descent optimizer. The paper will be presented by Abhijit S. Do we have Mr. Abhijit or the co-author for this paper? It seems not. We'll move towards our next paper. The next paper will be presented by Kirtan Patel, and the paper title is Classification of Indian Soil Types Using Deep Learning from Satellite Images.
Hi, am I audible?
Yes, sir, you're audible.
Yeah, I'm just sharing my screen.
Sure, sir.
Yeah, is my screen visible?
Yes, sir, your screen is visible.
Yeah. Can you see the PPT?
No, sir, we are still stuck on the Chrome page.
Oh, yeah, now maybe.
Yes, sir, now the PPT is visible. You may please continue.
Okay. Hello, everyone. So, the paper I'm presenting is
Excuse
Classification
me,
of
sorry to
Indian
disturb.
Soil Type.
Can you
Yeah.
put your PPT in a slideshow mode? First, enable the editing, please.
Mr. Kirtan, are we facing any technical issues?
Sorry, I was just having internet issues. Yeah, now I'm okay. Now you can see my PPT in the presentation mode.
Yes.
Yes, sir, it's visible.
Yeah, sorry for the delay. So I would be like to present classification of Indian soil types using deep learning from satellite images. So basically, we have used a deep convolution neural network, including transfer learning, to classify different types of soils. So for sample, we have taken four types of soils: alluvial, black, desert, and red. We have taken about 800 images, which were captured by Landsat 8 satellite. 200 images of each soil type of alluvial, black, desert, and red. And the models that we used were DenseNet, Efficient NetB5, XSection, and ResNet 50 for image classification. And after doing the training, we found out that Efficient NetB5 got the highest accuracy of 98.75. So in this, firstly, we have taken pre-trained models and then we have added another fully connected layer. And in the output, we have used softmax classifier. And for in order to get the evaluation, we have taken recall, precision, F1 score, confusion matrix as the parameters to compare the models. These are the related works like Singatel, he used agricultural land usage using deep learning. Srivastava, he used computer vision for classifying soil. Landjaver used soil picture classification using VGG19 exception. These are the other related works. So we have taken the data set and we have passed through four models. And after that, we have added fully connected layer of 512 neurons to decrease the number of training parameters. And for the output, we have taken four neurons as we have the four classes, alluvial, black, desert, and red. So the epochs that we took for training were like 25. The batch size was 32. The learning rate was 0.001. we have used the Adam optimizer for classification, and we use 80% of our images for training and 20% for testing. So the data set that we took was taken from USGS Earth Explorer website. In that, the Landsat 8 satellite, it actually had two of its terminal. One was TIRS, and the second one was operational OLI. Uh, it took like nine spectral bands, which were visible from naked eye using near infrared and short light wavelengths. So basically, the small cities, farms, they could be easily distinguished using its photographic capacity. After testing, we find out these were the outputs, like exception had 91.25, ResNet had 98.44, which was quite similar to Efficient NetB5. DenseNet had 97.50, and the highest was achieved by Efficient NetB5. This is the accuracy versus epochs graph. So we can see as the number of epochs increases, the accuracy started increasing till 23. After that, it came down and it reached the highest accuracy in 25. And as the number of epochs increased, the loss also started decreasing. This is the confusion matrix. So, in order to conclude, I would like to say that we have taken four soil types: alluvial, black, desert, and red, and these were passed through four different CNN models: ResNet, Exception, DenseNet, and Efficient NB5. Out of which Efficient NB5 got the highest accuracy of 98.75. In future, we can use different data set by we can add other images, and we can also include other soil types to increase the accuracy. And also we can take other written CNN architectures and just cross check with them to further improve the accuracy of this result. These are the references. Thank you.
Yes, the presentation was really good, Kirtan, and
Yeah,
we have done lots of work on it. That was very nice. The
thank you,
data
ma'am.
set which you are using, so what parameters they are including into it? When you are saying that you're doing the soil study for agriculture, I suppose. So what were
It's
the
for
different
SIAPs.
parameters?
Ma'am, we took the data set was already there on USGS Earth website, so we directly took the data set from there and basically did the soil type classification using the data set of four different major soil types that are found in India, that are alluvial, black, desert, and red.
Okay. And did you perform the EDA on it?
No, ma'am.
So that should be the very first step which you should do it, and depending on it, we choose the algorithm which will be applicable to it. That is, multivariate analysis could be done out of it. Okay. Yes. And if
Yes.
suppose the real-time data is being taken of the soil,
Yeah.
so, have
Yeah.
you studied something about how to get the real-time data, and at that moment only suggest the farmers that what a type of crop should be grown in that soil?
Uh, we haven't thought about that. For
Yes.
real-time data, maybe we need to incorporate that.
Yes, so because you being from India, I think the thing which is going here is like the real-time applications where it should be a mobile app in a regional language, and the farmer should be able to get the output in just a few seconds or few minutes, so that they are able to decide what type of crops should be grown. So you can carry your work
Yeah,
forward with all these things.
like we can create an app by which they can
Yeah,
upload a picture of the soil
yes,
and the module will suggest them that this type of crop can be grown on this soil.
Yes, yes, yes. That's all from
Yeah.
my side, Kirtan.
Thank you
Yes,
so
Dr.
much.
Jocelyn. Dr. Jocelyn.
Yeah. Yes, thank you, ma'am. Good afternoon and congratulations to the presenter. This is my question. What is the primary objective of this research, sir?
Okay, so primary objective of this research was basically to classify the different soil type and to find out that which transfer learning module can be is best appropriate for classifying this soil type. So in that we used four different, and out of that we found out that efficient NetB5 was the most effective transfer learning module because it increased the number of training parameters very less, which is the key point of transfer learning, why we chose this approach.
Mm-hmm. Okay. So may I just ask what particular part of India are you into?
Oh, so basically we took four major like alluvial, which is found out in the middle of, and the red soil type, which is found in the west of the India. The black crop, it is mainly found in Mediterranean areas. So we
Uh-huh.
took the major four type of soil which are found all over India. Most the top four number of soil types. We didn't
Okay.
include the other soil. Yeah.
Which of this type of soil is commonly used?
Mostly alluvial is used because alluvial is found mostly in India, because red is
Mm-hmm.
mostly found in Rajasthan, and black is only found in plateau regions like Maharashtra, but alluvial is mostly found all over India.
Oh, okay. So I think I have no more question. You have a very interesting study. Okay, congratulations.
Thank you so much. Have a nice day.
Thank you.
Thank you.
Thank you, sir. Thank you, ma'am. Now we'll be moving towards our next presentation. The next paper will be presented by Katya Muambia. The paper title is Methodological Advancements in Mobility Pattern Discovery for Disaster Response, a Critical Comparative Review. Do we have
Thank,
the author?
yeah, I'm here. Thank you for,
Yes,
I'm going to share my screen right
sure,
now.
sir.
Here. Um, am I, is it visible there?
Yes, sir. Your screen is
Yeah,
visible.
yeah.
Good. Yes, this paper we worked together with Professor Dr. Nirbey Chobe from Ganpat University. It's about methodological advancement in mobility pattern discovery for disaster response, a critical comparative review. Here is the agenda, purpose, methodology, key finding, contribution and conclusion, and future direction. The purpose of the study was to critically evaluate how mobility pattern discovery method evolved between 2018 and 2025 to support disaster response, evacuation planning, epidemic forecasting, and resilience assessment. And to assess, secondly, to assess how advanced computational techniques like deep learning, graph, neural network, agent-based model, reinforcement learning, and generative model address persistent challenge such as data bias, limited generalizability, and ethical constraints. And thirdly, or finally, the purpose was to identify methodological breakthrough that enable predictive, adaptive, and equitable crisis mobility intelligence. The methodology is just we applied a structured methodology. We went through this process, one systematic synthesis of peer review literature in between 2018 to 2025 comparative evaluation of computational techniques across multiple disaster contexts. And secondly, we analyzed we made analysis of mobility data source, bias type, and mitigation strategy. And finally, we identified, we made identification of cross-cutting gap and strategy priority for future MPD research. What's the key finding? Our critical analysis reveals several important findings. First, the mobility pattern discovery has shifted from descriptive to predictive and prescriptive capability. Descriptive method summarize past mobility pattern, just respond on the question, what happened? Meanwhile, predictive method forecast future, what is like to happen, and prescriptive is just about recommendation of action, what action should be taken. So the second finding is about COVID-19 acted as a major catalyst for the MPD. And we understood that it was really used. Unprecedented mobility data access accelerated the adoption of deep learning, GNNs, LRM, and synthetic mobility generation. Third, we had identified systematic data bias like sampling, spatial bias, behavior bias, access bias, and sociopolitical bias were widespread. Fourth, integrated approach outperformed single method. And finally, we found also the key finding about new insight into urban resilience, where recovery is not homogeneous, it's just heterogeneous phenomenon. And we secondly found a new insight into urban resilience about the strong long tie, closer high trust relation between people that is critical to drive epidemic spread and network vulnerability. The contribution of the study, first, we proposed a roadmap for generalizable, equitable, and privacy-preserving mobility pattern discovery framework. And then we provided a comprehensive synthesis of methodology advances across data, model, and applications. And finally, we emphasize a co-design with policymakers and humanitarian actors to bridge the gap between research and practice. In conclusion and future direction, the study shows that mobility pattern discovery has entered a new era shaped by big data, generative modeling, and network-aware intelligence. The field is shifted from reactive analysis toward anticipatory real-time decision support, and it's also revealed that urban resilience is far from uniform recovery unfolds as mosaic of neighborhood level trajectory rather than a single smooth citywide curve. And several key directions emerge from addressing the mobility pattern discovery. Firstly, developing models that are generalizable and transferable across region and disaster type, supporting by domain adaptation and synthetic data. Second, the direction is building ethical privacy preserving data ecosystem that enable rapid yet responsible information sharing during emergency. And then we found out, we proposed this direction about designing equitable decision support tools that incorporate demographic aware analytics to represent vulnerable groups accurately. And finally, strengthening collaboration with emergency managers, NGOs, and policymakers is really essential to assure interpretability and real-time usability. Thank you for listening.
That was really very nice, Katya. And yes, you are in the proper direction. But have you started with any practical implementation?
The study is going together with a large study related to a GIS and ABM model for evacuation of people from volcanic hazard. And we were also interested on the mobility of people. We wanted to know what with the advancement of the technology, how we can deal with the movement of
Uh,
people.
okay.
So
Have you suggested any suggestions of how the decisions should be taken?
we just provide future improvement, future direction, like using generative model, which are very, very interesting because we can exactly provide some patterns from the existing data. We can not only forecast, but suggest how people can move in such uh, emergency. And we didn't provide any practical thing, but we just suggest some future direction for,
Thank you. Thank you.
yeah,
Thank you.
yeah.
Yes, okay. Good afternoon, Mr. Katya.
Good
Um,
afternoon.
you have a very nice study, and I would say that well, with this kind of study, this is quite unique. Now, my question is, what inspires you to make this kind of study?
As I've respond to Madam, I'm doing a research on how to evacuate people from volcanic hazard, and
Uh-huh.
I'm interested on how how the technology is advancing in such situation to know about mobility pattern of people. Is there any involvement related to, for instance, predict? Because basically pattern was used in evacuation, it was descriptive only. But as we understood that, we can go beyond descriptive analysis to forecasting, even to suggest how it can become, even with synthetic data, with generative large language models. And it was really interesting to know how far the technology is evolving. Yeah.
Next question, okay. What do you think will be the impact of this study, especially to your place?
Impact of this study is very interesting to all the researchers, like all the research in computer science, especially in artificial intelligence. They can really, we can work together to try to make some models, especially related to to forecast and to predict. It can be helpful, very really helpful. Even policymaker will need all such studies from the researchers.
Okay, so thank you so much. I have no other question.
Thank you, madam. Thank you, ma'am.
Thank you, ma'am. Now we'll be moving towards our next presentation, and the next paper title to be presented is Modern Web Development Technologies, a comprehensive review to be presented by Arpan Singh. Do we have Mr. Arpan or any of the co-authors for this paper?
Yes, sir. Yes, sir.
Sure,
So I will share my screen.
sure. So will you be presenting in place of Mr. Arpan?
Yes, sir. Yes, sir.
Sure. So are you facing any network or technical issues?
Is my screen visible, sir?
Yes, sir, your screen is visible and we request you to put it into a slideshow mode. Yes.
Yes, sir. So can I start?
Yes, sir, you may.
First of all, good afternoon, respected conference chair, honorable professors, and fellow researchers. My name is Arihant, and today I'm pleased to present our research paper titled Modern Web Development Technologies, a Comprehensive Review. I'm presenting this work on behalf of the first author, Arpan Singh, as part of the collaborative research efforts by our team from Arya College of Engineering, IT. In today's digital world, web applications are no longer limited to a simple websites. They power healthcare platforms, financial systems, education tools, and e-commerce solutions. The objectives of our paper is to analyze how modern web technologies have evolved and how they contribute to scalable, efficient, and sustainable digital systems. One second. Okay. So I start with the World Wide Web has undergone a significant transformation over the last 3 decades. In the first Web 1.0 era, the web consists mainly of static read-only pages. We can just only read the information. And after that, Web 2.0 come, and in which social platforms like YouTube, Facebook are come in which the user can create their content. However, early web systems depended heavily on priority plugins like Flash and Silverlights, which raised serious concerns regarding security, compatibility, and sustainability. These challenges lead to the emergence of open, standardized technologies, which now form the foundation of modern web development. Hmm. Our paper examines the evolution from Web 1.0 to the modern web of the 2020. The modern web, it is characterized in three: Web 1.0, Web 2.0, and Web 3.0. In the modern web, real-time communication, rich client-side application, distributed and cloud-native architectures. Uh, in the modern world, today world, users are no longer passive readers. They are active participants interacting with full-scale application directly inside the browser and building dynamic websites. These are core technologies of web development like HTML5, CSS3, and JavaScript. HTML5 is introduced semantic elements, multimedia support, and better accessibility. It removes the dependency on third-party plugins by providing native audio, video, and graphic support. And after that, CSS is used for styling and layout. In this motorized design systems for faster updates, enable animations, gradients, and responsive layouts. These features allow developers to build mobile-first and device-adaptive interfaces, which is essential for sustainability and accessibility. After that, JavaScript. JavaScript evolves into a powerful asynchronous language capable of handling complex application logics. In which it is a core scripting language that derives from dynamic behavior. In this, we use REST APIs to interact with the server and client, and also write the logics how the API can work. These three technologies transform the browser into a full application runtime environment. After that, our research highlights several modern JavaScript API that significant. Oh, so sorry, can't complete all this. Okay. Uh, After that, our research highlights several modern JavaScript API that significant enhance web capabilities. WebSockets. We use WebSockets in web development to enable real-time communication, which is essential for chat systems, dashboards, live update. Server workers allowed application to function offline and catch resource efficiently. These features reduce server load, improve performance, and enhance user experience, contributing to efficient and sustainable web system. In this, we use WebSockets, Geological API, WebSockets API, server workers. And then architecture palette diagrams. In this a major focus on of paper is the artificial architecture shift in web development. In the traditional monolithic architecture tightly couple all components, making systems harder to scale and maintain. Modern systems adopt separating front end, back end, and services and combine after that microservices. And so in microservice architecture, microservice divides the application into small independent services is responsible for a specific function. This approach improves scalability, fault isolation, and deployment flexibility. Companies like Netflix, Amazon, and Uber widely use this architecture for global scale applications. Jamstack architecture. Jamstack is a JavaScript API and markup focused on pre-built pre-built functions and dynamic APIs. This model provides mainly faster load time, enhanced security, and cost-effective scalability. Jamstack aligns strongly with the goals of sustainable development due to reduced server overhead. Modern web technologies are actively applied across multiple domains: e-commerce, AI integration, healthcare, education. In e-commerce platforms like real-time inventory systems, healthcare in which dashboards for patient monitoring, education platform offering interactive learning. Looking ahead, future trends includes AI assistant development as first architecture, web assembly for near native performance, servers computing for cost efficient scaling. These advancements will further strengthen all the web as a sustainable intelligent and computing platforms. Uh, so conclusion to conclude, evolution of web technologies represent a major leap in digital innovation. The standardized of HTML5, CSS, and modern JavaScript, and all the APIs eliminated in this. It is also used to enable security, to build scalable applications, and the architecture paradigms like microservices, Jamstack have transformed how applications are designed and deployed and maintained. Today, the web acts as a universal application platform supporting diverse domains from artificial intelligence, healthcare, and education. As a web technologies continue to integrate with AI, cloud computing, and as platforms, they will play a critical role in shaping the future of sustainable design and digital systems. So all the function is like to making the web smarter, faster, more adaptive than ever before. So there are some references, and thank you everyone.
Yes, Arihant, that was a good literature survey review you have done. But are you in the practical implementation direction right now?
Yes, ma'am.
Yes. So what are you doing? What
So
work
ma'am,
are you proceeding with?
so ma'am, in my college, we are building a interview a project in our final year. In this, we build a full stack project. In HTML, CSS, JavaScript,
Hmm.
and also backend technologies like Node.js.
Okay. Okay. Thank you, Arihant.
Thank you, ma'am.
Okay, good afternoon. Good afternoon to I don't know, maybe good morning on your part, Mr. Arihant. Now, this is my question. What do you think are the most significant and advancement in the trends that you find out based on your study?
Uh, and can you please repeat?
What do you think are the most significant and advancement that you have found out in your study?
Arihant, most significant methods you found out in your studies.
Uh, ma'am, can my ask you my
May I
friend
speak?
ask
I'm the
question?
Yes,
part of the
yes,
team.
yes. Yes, Ashish. Yes.
Okay, so most significant part we have research, right? So while building the interview AI application, we have done interview AI application. We have used many modern web technologies like Next.js, serverless function, and many more. So what was your question again? I'm confused.
What is the
Most
most significant that you found out in this study?
Okay, so most significant I found out in this study. So what we have found in this study that from Web 1 era to Web 2.0, the modern technologies have evolved majorly. Now we use load balancers, microservices architecture to scale an application, to power up an application, and to optimize the APIs and WebSockets. So yeah, that's all I want to say about the sustainability.
Okay, thank you, sir. Now, the last question is that how did you try to evaluate this study? Did you do it alone or you are in a group? And
No, we are in a group. We have done in group. So yeah,
in the near future, do you plan to expound on this study and do you need collaborators too?
yeah, we need some collaborators. We have uh, from this study we have built an application. I must say we have used AI in that application. We have used the Gemini API. So what our application do is whenever a user inputs the job role, their resume and their skill set, the application generates an AI interview environment for them so they can practice their interview. Then AI gives them the real time feedback on their responses based on their responses. And for the collaborators, we would like to collaborate with others and we would like to get some more guidance on this research paper.
Okay, so thank you so much and congratulations.
Thank you, ma'am.
Uh, Thank you, ma'am.
Thank you, ma'am. Thank you, authors. We'll be moving towards our next presentation. The next paper to be presented is Object Detection using Image Recognition, and the paper will be presented by Pratham Jaiswal.
Hello,
Yes, sir.
I'm sharing my screen.
Sure, sir.
Wait. Hmm. So, can you see my screen?
Yes, sir. Your screen is visible.
Wait. Okay. So, good morning, everyone. Today, I'm presenting our work titled Object Detection using Image Recognition. So, our motivation for this project comes from the increasing number of two-wheelers accident, especially in a country like India, which have densely populated cities and all that. So, where helmet violations are common, manually monitoring by traffic authorities is often slow, inconsistent, and prone to human error. We wanted to build a system that automates both helmet detection and then license plate recognition in real time. At the same time, the system must work in a challenging conditions such as motion blur, low light, changing weather, and varied license plate styles. So, our goal was to design a unified deep learning pipeline that solves both tasks efficiently and run on affordable hardware. So, let me go through the system overview of my implementation. So, our system performs two tasks simultaneously: detect whether the rider is wearing a helmet and recognize the vehicle license plate for identification or enforcement to the enforcement authorities. It will send that if they are wearing helmet or not, according to the license plate detection. So a key innovation in our work is the context-aware model selection. So what we have done, we have if the vehicle is moving fast, we'll send the image to our YOLO model, which is optimized for fast-moving objects. Also, if the vehicle is slow or stationary, like in traffic light, signal lights, or petrol pump station, so our faster RCN model will work, which provide higher detection accuracy because we want to detect higher accuracy at the traffic signals and petrol station uh, accurately. For license plate recognition, we use YOLO V5 to detect the plate region and then apply parallel OCR to extract the license number from that uh, number plate. The entire system is deployed using Flask, a backend, and the PostgreSQL to is used to verify the detected plate that belongs to an authorized vehicle. So the model architecture will be like that. YOLO V11 we have used is a fast single stage detector. It uses improved feature extraction in modules and can detect object in real time with high robustness, especially used for moving vehicles where motion blur is present. For faster RCNN, I can say uh, is a two-stage detector. It uses ResNet 50 backbone and feature pyramid networks. This gives very high accuracy for stationary object where speed is less important. For license plate, use YOLO model to which identifies plate locations even in clustered scenes. The detected plate is then cropped and passed to paddle OCR. The paddle OCR includes a DBNet based detector and a CRNN based recognizer, which together handles distortion, different fonts, and partial occlusion. The combination of these three architecture ensures that we get both speed and precision based on real-time traffic conditions. So I will go through the methodology of how the data pipeline is working. Uh, for helmet detection, we have taken a data set of around 1500 real-time traffic images spanning different lighting and weather conditions. We added data augmentation, including rotation, brightness, adjustment, and flips to make the model more robust. For license plate, we use data set of 15 Indian number plates, fine-tuned on YOLO V5 model to from previous from that. Paddle OCR was used to pretend OCR weights. We have trained our models on NVIDIA RTX 3050 GPU. We have used for Adam Optimizer for YOLO models and SGD for faster RCNN. Uh, Go to the next thing. So this is the steps in the pipeline. So the capture is we capture the frame from CCTV or a normal camera. Then we apply frame differencing to understand whether the vehicle is moving or not. So after that, based on the decision, the frame is sent to the whether it is a moving, then it will send to a YOLO V11 model, or if the vehicle is stationary, it will go to a faster RCNN model. Then second YOLO model detects whether the number plate is present on the vehicle or not. It will get the number plate. Then paddle or CR extract the text from the number plate, and then text will be sent to a PostgreSQL database, which verifies whether the number plate is registered or not, and it will extract the details of the vehicle owner. So the result and findings, I can say we have reached a real-time processing of 20 FPS on RTX 3050, which is suitable for practical traffic monitoring. Um, For helmet detection, we have used Yellow V11, which gave an excellent performance on moving vehicles. Faster are seen and perform better on stationary bikes. We have observed, given giving high accuracy. For ALPR, combining YOLO V5 and pedal OCR gave 96% accuracy, even under partial occlusion and low resolution. So I will go next. Huh. We'll go to the conclusion of the work. So, to conclude, we have developed a context-aware dual stage traffic surveillance system that perform both helmet detection and license plate recognition in real time. By intelligently switching between YOLO and faster RCN model based on the motion of the vehicle, we maximize accuracy without sacrificing speed. The system is cost-effective, running smoothly. Uh, we can expand uh, our this project to a larger system by improving the by training our models on larger data sets and using more robust hardwares. So that's all overall my research and my findings. This is the sample output that I was getting through my model. This is showing helmet for wearing helmet. This will be shown with the precision. This is no helmet precision. It's shown. So thank you. That's all from my side. Uh, ma'am, you are mute, I guess.
Yes, very impressive work. It was very impressive work, and it really is a need in India today.
Yes, yes, sure.
My question is, have you performed any cross validation for it? If it
Uh,
is practically working, any cross validation?
I've performed not on a very big scale, but I have performed in from my laptop on a small stage. I have performed it, like captured the video, then processed into my system. Then it is showing results. Also real time. If I open my laptop camera and do the processing of the this model, then it is showing results.
Mm, okay, that's good, but it could be implemented your model could be deployed practically and
Mhm.
could be implemented everywhere if the cross validation and testing is being done on a wider scale.
Hmm.
Okay,
So for
okay,
that, I want to add. For that,
yes,
we
yes.
need a higher data set to for the model to be trained on and a very good hardware.
Yes,
Secondly, can I be in?
yes, yes, yes.
Yeah, so actually, for all that, we have to install the cameras and all at the traffic station. We have to seek permission because currently we are also undergoing another project related to vehicle tracking system and all. But then it's taking lot of time for us. We are like, you won't imagine, still since 1 year, we are just following up the people, personals, and we are just asked to go from here to there to there, and nothing is in place. So the
Uh,
things like practical implementation is really next to impossible in such a short duration. But yeah, in the future, we
yes,
are
Anita ma'am,
into
Anita
yeah,
ma'am.
yeah.
Yes, I would like to have a suggestion in such
Hmm.
case
Hmm.
that you could have a collaboration or tie-up with the traffic police department.
Yeah, exactly. That's what I'm saying.
Yes,
That's what I'm trying
yes,
to tell you, that
yeah.
we are currently executing another parallel project, and that's all related to vehicle terminal unit, and we are like in touch with the police department and all. So for the seeking permission to install the cameras and all, it's taking lot of time. So these
Yeah.
issues like they are not at a fast pace, and
Okay.
definitely we that is in our mind to deploy it in real practice.
Yes, yes. That
Yeah,
that
yeah.
is very nice, Anita ma'am.
Mm.
Congratulations on your work.
Yeah.
Thank
Thank
you.
you.
Thank you very much from my side.
Okay,
Yes, Dr. Joshi. Yeah.
yes, thank you, ma'am. Thank you, doctor. Well, congratulations to the researcher of this very interesting topic. Well, my first question is this just for the motorcycle or for the helmet?
Uh, Currently we have trained our model to detect only helmets, but we can explore more things to to be detected, and be do future work can be expandable for that. Like
Yes,
we can use in a car, if the person is wearing seat belt or not, we can do that also. Hmm.
okay. Well, that's nice. I was looking a while ago at the picture, and it seems that it's only applicable on the helmet. If I may suggest, so why not use also in cars and also trucks and maybe in all types of vehicle? This will have a good impact. Now, another question is, well, you've made mention. Is this just a pilot study, or you have started a pilot study into a certain area, or is it the a certain provinces or cities in your town is using this?
So we are in India, so here is a very big problem of accidents, and most of the accidents can be prevented if the rider is wearing a helmet. So that's one of the issue that I come across to solve. So that's the main motivation of this project, I guess, from my side.
Okay, thank you so much.
Okay.
No other question.
Okay, thank you.
Thank you, sir. Thank you, chairs. Now we'll be moving towards our next presentation. The next paper will be presented by Chandana R, and the topic is Prediction of Surface Morphology and Gas Sensing Parameters from SEM Images using Hybrid Deep Learning and Machine Learning Models.
Yeah, I'm sharing the screen now.
Sure, ma'am.
Is my screen visible?
Yes, ma'am, your screen is visible.
Yeah, okay. Yeah, good afternoon to everyone. I'm Chandana R. Today I will be presenting my work on prediction of surface morphology and gas sensing parameters from SEM images using hybrid deep learning and machine learning models. So, electrospun nanofibers are widely used in the areas such as drug delivery, tissue engineering, gas sensing, and filtration because they offer high surface area and tunable pore structures. One of the challenges in this field is that predicting the surface morphology and the gas sensing parameters from the manual feature extraction from SEM images and our extensive physical experiments are very it is also a labor intensive and also it is very expensive. In order to address this challenge, we explore a hybrid deep learning and machine learning model. In this approach, we have used convolution neural network which automatically extracts the deep features from SEM images, and random forest regression is used to perform the accurate predictions. And this hybrid method reduces the experimental effort and offers a fast and automated prediction pipeline. So the main problem we aim to solve is predicting the gas sensing performance directly from the surface morphology, traditional prediction alone, or on the gas sensing performance alone. So there is no integrated end-to-end solution connecting the SEM image morphology with the gas sensing behavior. So therefore, there is a need to build a model that can link a full chain from SEM images to morphology and then to sensing behavior. So to solve this, we propose a two-stage hybrid deep learning and machine learning pipeline. In stage 1, we predicted the two important morphological values from the SEM images. And in stage 2, by taking the predicted morphological values and we use them in the to predict the gas sensing parameters such as sensitivity, selectivity, response, and the recovery time for 4 gases: CO2, NO2, and NH3 and H2S. And we evaluated the multiple CNN architectures, including ResNet 18 and ResNet 50 and MobileNet V2 combined with the random forest regresses. The models are implemented in the MATLAB and evaluated using R-square, RMSE, and MAE metrics. Overall, the hybrid CNN and RF approach achieves the significantly higher accuracy when compared to the standalone models. And it also establishes a strong link between morphology and the sensing behavior. So many researchers have been explored the use of CNN for the nanofiber analysis, and several machine learning models have been used to predict the fiber diameter and the roughness separately. So we have identified three major gaps in the existing literature survey. So first one is no existing work predicts the both surface roughness and the fiber diameter simultaneously. So second is the combined use of CNN and RF model for the joint prediction of morphology and the gas sensing parameters has not been explored yet. And third one is the most of the studies do not quantify how morphology directly impacts sensing behavior such as sensitivity, selectivity, response time, and the recovery time. So the novelty of our work lies in we developed a two-stage hybrid deep learning and machine learning pipeline, which is capable of predicting both morphology and the gas sensing performance. And we demonstrate that the hybrid CNN and RF approach achieves significantly high accuracy when compared to the standalone models like CNN and RF. We establish a direct quantitative link between fiber morphology, especially diameter and the roughness, and the gas sensing behavior. And finally, this approach is fully of non-invasive, reducing the need for the physical experiments. The main objective of this work is to fabricate PS and PCZ nanofibers with TTIP and AL2 fillers and to extract the morphology features from the SEM images using CNN and RF and hybrid models, and to predict the gas sensing parameters such as sensitivity, selectivity, response time, and the recovery time. And last is to compare the different model configurations in order to identify the most accurate approaches. So this is the data set we have used. We have the dataset consists of 44 images with the resolution of 1280 into 960 pixels. These images were collected after the electrospinning process. Each images was analyzed to obtain the ground truth values for the diameter and the roughness and the gas sensing parameters. This dataset forms the foundation for both the stages of prediction. Like in the stage 1, we predicted the morphology, and in the stage 2 we predicted the gas sensing performance. So this is the flow chart which shows the entire workflow of the system. We begin with SEM image collection followed by the manual ground truth extraction of diameter and the roughness. Next, SEM images are passed to the CNN model and to extract the deep features, and these features are used to predict the morphology values using the random forest and the hybrid models. In the second stage, the predicted morphology values are used as the input to the another regression model that forecasts the gas sensing performance. Finally, the models were evaluated and compared based on the accuracy. So these are the results. As we can see here, CNN alone performed poorly due to insufficient data set, and random forest performed moderately, and however the hybrid accuracy. So ResNet 50 plus RF combination performed the best among these models, with surface roughness achieved of R square of 0.87 with RMSE of 3.92 and mean diameter achieved an R square of 0.78 with RMSE of 4.61. So coming to the gas sensing prediction results, it also gave the best result for ResNet 50 model, but CNN model struggled, and random forest model were moderately accurate. So thus the RSNet 50 combined with the RF is consistently the most reliable model for both morphology and the gas sensing prediction. To summarize, we developed a two-stage hybrid deep learning and machine learning framework that connects SEM images to morphology and then to gas sensing performance. The best performing model was that ResNet 50 combined with the RF model, and we also established a clear relationship between the morphology and the sensing behavior, showing that the higher roughness and the smaller diameter lead to the improved sensing performance. And the framework provides accurate non-invasive prediction with the roughness R square of approximately 0.87 and diameter of 0.78 and the sensing R square up to 0.74. So, thank you.
Yes, that was good work. And
Thank you.
the accuracy parameter which you have used is RMSE, MAE, and R square.
Yes, ma'am.
So when you're comparing the three parameters, which parameter you find to be more accurate?
Ma'am, like we have to compare all the three, but R square value, like if it is nearer to 1 means it is more accurate one, and the RMSE and MAE should be lower, ma'am, like lower than 5. It should be lower than 5. Then only we can say that this model is accurate.
Okay. Any cross validation?
No, ma'am. I didn't use
Okay,
any
so
cross.
yes, yes. So you have to use some cross validation technique to find out that the accuracy which you have got is in the proper direction or not. Okay.
Yeah,
Yes.
sure, ma'am.
Yes, yes. Thank you.
Yeah, sure. Thank you, ma'am.
Okay, congratulations, ma'am, for a very nice presentation. Now, as I was saying a while ago, your presentation, this is my question. What are the different challenges that you encountered in this study?
And like due to a small data set, we couldn't able to find the accurate values. So by using more, like more means greater than 150 SEM images, if we use means we can get more accurate values, ma'am. So that is the main challenge. Small data set was the main challenge.
What about the time? Is it not time consuming, or what can you say?
Yeah, ma'am, and it took me 3 months. It was time consuming, ma'am.
Okay, so I have no other question. Thank you so much and congratulations.
Thank you, ma'am.
Thank you, ma'am. Thank you, chairs. Now we'll be moving towards our next paper, and the next paper will be presented by Punit Jaiswal on the paper titled Real-Time Web Application Using WebSockets and Node.js.
Am I audible?
Yes, sir, you're audible.
Yes, sir. Screen is coming?
Yes, sir, your screen is visible.
Yes, sir. So, good afternoon, everyone. I am Punit Jaiswal. Today, I will be presenting our research paper titled Real-Time Web Application with WebSocket and Node.js, which focuses on building scalable, low latency web system for modern real-time requirements. So, now we move to the next slide. So here comes the index part. Here we will discuss about the introduction part. So today's web users expect instant responses, whether it's live chat, notification, or dashboards. Traditional HTTP follows a request response model, which is inefficient for real-time communication. So in this paper, we explore how Node.js, with its event-driven architecture, combined with the WebSockets, enable persistent two-way communication. Our goal is to demonstrate how this combination improves performance, scalability, and user experience in real-time web application. So now we move to the next slide. What are real-time web application? Real-time web applications are systems that deliver data instantly without requiring page refreshes. They support continuous two-way communication between the client and server. Common use cases include live chat systems, collaborative editing, online gaming, live notification and feeds, stock market or sensor dashboards. Now we move to the next slide. Understanding Node.js. So Node.js is a JavaScript runtime built on Chrome V8 engine. Key strength lies in its non-blocking, event-driven input-output model, which allows it to handle thousands of concurrent connections efficiently. Unlike traditional server models that create a new thread per request, Node.js uses a single-threaded event loop, making it ideal for real-time application. Commonly used with the Express.js for building web servers and APIs. Now we will move to the next slide. Node.js advantages for web application. Node.js offers several advantages. High performance, high performance due to V8 engine and excellent scalability for concurrent users and JavaScript on both front-end and back-end, reducing development complexity and a vast ecosystem of NPM libraries, lightweight and resource efficient. These features make Node.js a strong foundation for real-time systems. Now we move to the next slide. Understanding WebSockets. WebSockets are the communication protocol that enables full duplex communication between the client and server over a single persistent connection. Unlike HTTP pooling, WebSockets eliminate repeated requests, resulting in low latency, reduced network overhead, real-time data exchange, and they are widely used in chat apps, live feeds, and online gaming. Now we move to the next slide. How WebSockets work. The communication begins with the standard HTTP handshake. Once accepted, the connection is upgraded to the WebSocket connection. After this, the connection remains open. Both client and server can send messages at any time. Data flows instantly without repeated requests. This makes WebSockets highly efficient for continuous real-time communication. Now we move to the next slide. Tech stack overview. Our proposed system uses front-end as HTML, CSS, JavaScript. Backend uses Node.js and Express.js. And real-time layer uses WebSocket using Socket.io. And databases uses MongoDB. And development tools uses NPM, VS Code, and Postman. This stack ensures scalability, simplicity, and ease of development. Now we move to the next slide. Create WebSocket server. In our implementation, we initialize an Express server, create an HTTP server, integrate Socket.io for WebSocket communication, handle client connection and message events. This setup allows real-time bidirectional communication with minimal server overhead. Now we move to the next slide. Connecting from the front end. On the client side, the Socket.io client library establishes a connection. The front end listens to server end and messages are sent and received instantly. This enables seamless real-time interaction without page reloads. Now we move to the next slide. Advantages. The key benefits of our approach include ultra low latency communication, bidirectional data flow, and efficient handling of thousands of users, reduce server load due to persistent connections, and cross-platform compatibility. These advantages makes the solution suitable for modern, scalable real-time applications. Now we move to the conclusion and future work. To conclude, our research paper demonstrate that Node.js and WebSocket provide a powerful and scalable solution for real-time web applications. They significantly improve performance, user experience, and resource efficiency. As future work, this system can be enhanced using Redis Pub, sub for distributed scaling, microservices architecture, advanced security mechanism, integration with cloud native performance, and uh, these are some references from which we have made our research paper. And thank you for giving me chance.
Yes, it was a good work. And any
Thank you, ma'am.
practical application you have performed?
Yes, ma'am. We have used. Yes, ma'am. We have used this technology in our latest project, Community Infrastructure Tracker, ma'am. So in this, ma'am, we have basically we have named our website as InfraSync. Node.js plays a central role in that entire backend system, and InfraSync is a community infrastructure management system where user report issues by uploading photos, description, and location details. It needs a fast and reliable server to handle all this operation. So Node.js is used to create the server, manage incoming requests, and ensure the system responds quickly, even when many users are active at the same time.
Okay, how do you think that your parameter is more good than the other tools, or your tool is more good than the other tools? Any comparison analysis?
Ma'am, actually, ma'am, it's we will try to make it deal in the real time scenario.
Yes, yes. So you're implementing a next project now. So there you can come out with some comparative analysis and prove that how your tool is more good or more advantageous than the other existing ones.
Yes, ma'am.
Yes. Yes. Thank you, Puneet.
Thank you, ma'am.
Hello, good afternoon, Mr. Punit. Now, my question is, what inspires you to make this kind of research?
Ma'am, in our country, we have many problems like street lights are flickering and potholes problems on the roads. And so I thought, ma'am, that we should solve this kind of problems and we should help government and take some initiative from our sides.
Okay. So, what do you think will be the impact of this, no, of this study once this is already transferred to the communities in your place?
Ma'am, we will try to launch in our city. Firstly, we will try to contact our local government service, local government body, and then we will try to uh, make them use of this our software system.
Okay. So yes, okay. Thank you. Congratulations again, and at least
Thank you, ma'am.
soon you will be applying this for SDG12, its partnership with the community. Congratulations.
Thank you, ma'am. Thank you.
Thank you, sir. Thank you, chairs. Now we'll be moving towards our next presentation. The next paper will be presented by Ms. Strong, and the paper title is The Impact of B2C E-commerce on Vietnam's Export to the European Union.
Hi, I'm here. Can you hear me?
Yes, ma'am, you're audible.
All right. So I guess this is my the last presentation of the section. So I just want to turn on camera and say hi to everyone. Okay. So can you see my slides?
Yes, ma'am, your screen is visible.
Is it visible now?
Yes.
Okay. So on to slideshow mode. Please wait a moment. Okay, is it in slideshow right now?
Yes, ma'am.
All right. So good afternoon, everyone. My name is Yuen. I'm from Vietnam, and today I would like to present my research entitled "The Impact of B2C E-commerce on Vietnam's Exports to European Union." And the presentation today will be divided into 5 parts, including introduction, literature review, research method, result and discussion, and some implications. So for introduction, right now, Vietnam is a highly export-oriented economy. And actually in 2019, the European Union accounted for more than 15% of Vietnam's total export value. So this makes EU become one of Vietnam's most important trading partner right now. And at the moment that I did the research, there has been several studies quantifying how IT or ICT or internet boost export values. However, they mainly focus on broad digital process rather than consumer-oriented B2C indicators. While in some research in Vietnam, they mainly focus on firm-level data, domestic impact. So therefore, the study will address the following research question. How does B2C e-commerce in EU countries affect Vietnam's export value to the EU during 2014 to 2020? So in the research method, this study is grounded in the gravity model of international trade, which explains bilateral trade flow based on economic size and trade costs. And the analysis uses panel data for 27 EU countries over the period from 2014 to 2020, and an extended gravity model is employed where Vietnam's export value to each EU country is explained by GDP of EU, GDP of Vietnam, geographical distance, FDI, net inflow into EU countries, and nominal exchange rate from euro to Vietnamese dong. And one variable, very special indicator I want to emphasize here is the B2C e-commerce index in EU. So this basically the symbol average of 4 indicators of internet usage, postal reliability, financial account ownership, and secure internet servers. All right. So regarding the data analysis and estimation, the study applies OLS, and then there was a multiplier test conducted. And we see that fixed effect model or random effect model will be more consistent and more efficient than OLS. And then Hausman test was conducted, and it shows that fixed effect model is preferred. So after that, further diagnosis tests were conducted to check for heteroscedasticity. That was heteroscedasticity in the research, but there was no autocorrelation. So that's why FGLS, feasible generalized least squares regression, is used. And here is the result. So from the result, you can see that all the explanatory variables have positive and statistically significant effects on Vietnam's export to the EU. And most importantly, the B2C e-commerce index has strong positive impact. 1% increase in B2C e-commerce readiness in EU country will lead to 0.63% increase in Vietnam's export value. So this indicates that advanced e-commerce in EU firms will reduce some search cost, transaction cost, which enabling them to identify and source products from Vietnam more efficiently. While GDP of EU, if this increase, it means higher purchasing power, import demand. And GDP in Vietnam also contributes positively by enhancing production capacity and competitiveness. So, which also leads to an increase in Vietnam's export value. Interestingly, after having the result, the geographical distance also shows a positive effect. So based on my research, this may reflect efficient logistics, advanced port infrastructure, some strong import demand of major Western European economies, and economies of scale in long distance shipping and goods consolidation, as you can see here, some huge demand will appear in some countries like this. And with shipping route is very straightforward. So that's why there was, I think this somehow weakened the distance as a proxy for actual trade costs. Okay, so for FDI net inflow into EU countries, so this will reflect the increase in financial resource, employment, and technology transfer, which means better access to foreign markets. And this means that EU country will import more energy, equipment, and intermediary products from Vietnam. All right, and then an increase in nominal exchange rate between the euro and Vietnamese dong has a positive effect as well. An increase in this indicates a depreciation of the Vietnamese dong, which lowers the euro-denominated price of Vietnamese exports. And this improves price competitiveness and stimulates demand from EU importers. Okay. So what is the implications after this? Based on the empirical findings, several important implications can be drawn for both policymakers from the government and exporting firms. So for the government, I think we need to strengthen digital trade facilitation, whether by improving digital infrastructure or enhancing online payment, and then simplify trade procedures by streamlining customs and import-export procedures and improving digital trade regulations. Then maintain supportive macroeconomic conditions. Ensure there will be stability to sustain export competitiveness and leverage positive spillovers from GDP growth, FDI inflows, and exchange rate dynamics. And last but not least, it's very, very important to deepen cooperation with EU partners, okay? And for exporting enterprises, we need to adapt to digitally advanced markets by developing strong online presence and e-commerce capabilities, invest in digital marketing to reach more buyers more efficiently, and optimize market and channel selections, which should be more suitable and aligned with the product characteristics, and manage the exchange rate risk effectively by applying flexible pricing strategies in response to currency movements and using risk management tools to mitigate exchange rate volatility. So actually, that's the end of my presentation, and I think it's time for Q&A from doctors, right? Thank you very much for your attention.
Yes, it was a very impressive presentation. Wrong, if I'm pronouncing it right. Ms. Rang, is it?
Trung is actually it's my family name, but my first name is Nguyen.
Nguyen.
Nguyen, yes.
Okay.
I'm from
Yes.
Vietnam.
It was a very impressive presentation. And yes, any practical outcomes of your research?
Practical outcomes, I think it's very hard to say because somehow my research will act as a base for some policy in the future. But for the practical outcomes, I think right now Vietnam is implementing a lot of new policies based on the awareness of this. For example, through the past few years after COVID pandemic-19, you can see a boom in e-commerce platforms here in Vietnam. We expand, you can see TikTok Shop is rising right now, or Shopee, Lazada, or even there would be some like they break down some barriers for customs or some kind of e-commerce platforms that I don't know technically, it's not my expertise. But for enterprising levels, from my observation, because right now after graduating, I am working as an HR in training. So the practical implementation that I can see is that some companies right now, they are focused on this a lot, and they start to develop training programs for their staff to enhance this.
Okay, thank you very much.
Yes, thank you very much.
Well, good afternoon and congratulations, Miss Duyan.
Thank you.
Yeah, I love your presentation. You've been talking about Shopee, you've been talking about Lazada. Now, do you have any idea as to who are mostly inclined into this kind of business, no, or who usually patronize it in your place?
So in European or in my place in Vietnam?
In Vietnam.
Oh, in Vietnam. Actually, right now, the government has implemented a lot of new policies, and e-commerce will act as like a key segment here in our economy. So most, I think, from my information so far, there has been around 70% business right here apply e-commerce into their business operations, whether to reach their customers domestic in the domestic within the country or its cross-border economies as well. But for European market, one product in Vietnam that we focus on a lot is some components for electronics and textile industry. They are the signature industry and some signature products that we usually export to EU. Yeah.
Okay. What about cosmetics?
Cosmetic. Actually, right now we have some cosmetic brands for cosmetic, but the exports value wasn't that much, wasn't very significant. Yes. So hopefully we can have
Okay.
more in the future.
Okay. Thank you so much and congratulations.
Thank you, doctors. Okay, I will turn up. It's the end, right? I will turn off the camera.
Thank you, ma'am. Thank you to session chairs as well. Moving towards our next presentation, the next paper to be presented will be presented by Mr. Abhijit. Yeah, will be presented by Mr. Abhijit S. And the paper title is an optimized model for heart attack prediction using SMOTE, Swish and mini batch gradient descent optimizer. Do we have Mr. Abhijit, the co-author for this paper? Seems not. We'll move towards our next presentation. The next paper to be presented is an IoT-enabled anti-vandalism and predictive maintenance framework for utility infrastructure, a ZESCO case study, and the paper will be presented by Chimuka Munde.
I'm here.
Yes, sir.
May I share my screen? Kindly confirm you can see my screen.
Yes, sir. Your screen is visible. You may please continue.
Thank you so much. I'll be taking you through this presentation. My name is Chimuka Munde, paper ID 91. This is the format that this presentation will follow. We'll have the introduction, literature review, and as shown on the screen. Introduction. Parastatal distribution infrastructures, such as ZESCO's power transformers, form the backbone of Zambia's economic development. Yet they face persistent challenges, that is technical degradation due to aging equipment, as well as deliberate vandalism. These assets are widely spread and often located in remote or peri-urban areas with limited physical surveillance and connectivity. This makes traditional manual inspection both insufficient and unsustainable. The consequences include extended service interruptions, increased operational costs, and compromised public safety. In response, Internet of Things and machine learning are changing the landscape for maintenance and protection of distributed infrastructure. IoT enables real-time data collection, whilst machine learning learns abnormal patterns indicative of faults, degradation, and tampering. ZESCO faces two challenges, that is our problem statement: frequent technical failures due to aging assets and reactive maintenance, as well as deliberate vandalism targeting transformer infrastructure and resulting in theft of copper windings and transformer oil. The aim: to design and validate IoT machine learning-based framework for predictive maintenance, monitoring, and vandalism prevention of ZESCO's transformers. Significance of this study aims to integrate predictive maintenance and anti-vandalism into a single IoT framework, thereby addressing two major causes of outages in sub-Saharan utilities. The research as well advances by combining two engineering frameworks with routine active theory. Finally, this study contributes to the sustainable development by strengthening electricity reliability and reducing economic losses. So thereby, we're contributing to the two SDGs, SDG 7 as well as SDG 9. For this study, two sites were sampled for the pilot study, that is the substation at the University of Zambia and a substation by the ZESCO workshop. Limitations of this study, the implementation of the prototype was restricted to two sites. They also had some hardware and cost constraints. Then by using low hardware costs, there was a restriction in terms of computational power and on-device storage and sensor precision. This study is anchored in two theoretical frameworks, the PMH as well as the routine active theory, as shown on the screen. For literature, amongst literature reviewed, the following are some of the gaps that were identified as well as the strengths of the works that have already been done so far. For the baseline study, data collection was collected using the sensor telemetry. And then for the data that's collected, it was analyzed using SPMS, SPPS, as well as Excel. And then visualization of the IoT telemetry was performed using the Grafana dashboards. For the model development, the following are proposed. That is an edge agent. We had the message fabric, which is MQTT, real-time API and backend, where we use a lot of REST API with WebSockets. For storage, we used MySQL and S3 for storage of images and videos. Then for dashboards, we used Laravel Livewire 3 as well with the high charts. For alerting, we used the Rule engine where we were sending SMS, WhatsApp, and email notifications. Then for security, we use TLS everywhere as well as JSON Web Token authentication. Sensor polling, or we're polling temperature, vibration, tilt, yaw, current, and environmental parameters with local checks. We had image snapshots, MQTT push, offline cache, relay control for the siren and strobe deterrence. So the key idea was decide locally and report globally. For our results, this was a dashboard that was implemented where we were combining the sensory information, communication, dashboard, and thereby displaying the information on the dashboard here. Operational monitoring was achieved as well using the same dashboard where we had network uptime exceeding 93%. Temperature readings remained within the range of 21 to 23 degrees Celsius with minor changes, fluctuations. Humidity varied between 47 to 49, which is consistent with the ambient levels in the environment. The slide shows the camera footage that was captured at one of the substations, the one at Levy, where we had human activity within the restricted zone. Further, we had another camera footage at Uza substation nighttime, where the AI video detection flagged multiple intrusions between 22:21 and 22:34, with a bounding area box tracking intruders despite low light, thereby validating the machine learning robustness. Our findings show that IoT machine learning frameworks extend beyond PMD into vandalism deterrence, and the African context demands edge economy, rugged hardware, and hybrid LP1 architectures. The RAT theory illustrates IoT as guardians, where we're embedding IoT-driven guardianship, improves asset resilience, service reliability, SDG compliance, and the deployment demonstrated that integrating IoT telemetry with machine learning-based CCTV analysis significantly strengthens transformer security and predictive maintenance. Practical insights, data and human activity around the Levy substation highlighted operational risks, that is workers and contractors, whereas alerts must be distinguished from genuine vandalism. Nighttime intrusion at the Unza substation showed rat theory in practice, where we had motivated offenders targeted assets under low visibility, but the IoT sensors and machine learning acted as digital guardians. For our conclusion, the research provides both a technical contribution, that is IoT machine learning framework tested in the real substations, and a contextual contribution that is demonstrating that African vandalism challenges reshape global PhD paradigms. By combining prognostic and health management and routine active theory, the study establishes a multidisciplinary foundation for future deployments that aim to make African power systems smarter, safer, and more sustainable. For future work, there is currently no large-scale labeled dataset for transformer vandalism incidents in Africa. Building such datasets, including environmental readings, IoT alerts, footage, would enable more robust machine learning models. A formal red team exercise is planned to evaluate GPS spoofing, camera blinding, MQT replaying attempts with stolen credentials. So the authors would like to acknowledge the University of Zambia, ZESCO Limited, for supporting the research, as well as the Ministry of Science and Technology for supporting. These are some of the references that were used in this study. And that brings us to the end of our presentation. Thank you.
Yes, it's a good research work. I think it is a funded project, isn't it?
Yes, ma'am.
Yes. So have you deployed your research work in the premises of the support which you are getting from your government?
Yes, so there's one. So for the pilot, we were requested to deploy to 2 sites as a proof of concept. Thereby, when that was done and they were happy with the test results, we further deployed to 1 more site close to the premises. We gave them access we gave them access to the dashboard just to view how the information is coming through. And then we had another discussion where now for the coming year, they're requesting for a deployment of 60 prototypes so as to further prove the concept.
That's good. And any flaws you have found it out?
Beg your pardon?
Any drawbacks you have found out?
So drawbacks, well, one of the drawbacks I've had is we have to change our weather box, because what we have noticed is now it's a rainy season currently right now. So we had one unit that actually gave up. It got soaked, so the equipment inside the weather box gave up. So one of the recommendations that we received is we should change our weather box to be weatherproof, but at the same time allow ventilation so that the equipment does not overheat as it continues functioning 24/7.
Thank you. Thank you. That's all from my side.
Yes, good afternoon, sir. This is
Good
my
afternoon.
question, and by the way, congratulations for a very nice study. Now, what are the challenges that you encountered in your study?
Okay, so at first was convincing the various stakeholders and getting approval to actually have one of the 2 substations shut down during operational time. That proved very difficult, but with support from the university, we were able to convince ZESCO, that's the utility company in my country, to give us a shutdown window to install equipment in 2 sites. This took over about 2 months just to get approval from the stakeholders. Further to that, also just getting the equipment in our country also proved to be a bit of a struggle. There were the shipping took a while. At some point, we even had bought wrong equipment, so we had to send that back so that we get the equipment that we prescribed for this study. So that was just some of the challenges we faced. Mostly getting approval from the stakeholders was a challenge to request for a shutdown of a substation.
Okay, I have no more question. Thank you so much.
Thank you, sir. Thank you, Chair. Moving towards our next presentation. The next paper to be presented is the paper titled Interpolation, Enhanced Nonlinear Regression and Machine Learning for Control Valve Characterization. And the paper will be presented by K. Vidyasagar.
Do we have the authors or co-authors for this paper?
Sir, can you please unmute yourself? Sir Vidyasagar?
Sir,
Yeah.
is it audible, sir?
Yes, sir. Now it
Yes,
is
sir.
audible.
Sir. I'm connecting, sir. Thank you for waiting for me. Thank you. So, yeah, good morning, sir. Good morning, madam.
Good morning, sir.
Actually, this is the work we executed in the laboratory, and we have two control valves. One is linearly operated, another one is quick opening control valves. The reason behind the characterization of the control valve is how the control valve is behaving. The behavior analysis is essential if you wanted to install into a flow stream, because the control valve behavior is influenced by across the. I might be introduced some yes, and I have to connect it in series with the control valve. All these components will influence on the characteristics of the control valve. In generally, I used to say the control valve is exhibiting linearly, but sometimes what happens in mid region or at the upstream region, the control valve exhibits a non-linear
Excuse me, sir.
characteristics. So how this model is
Excuse me,
behaving, I
sir.
would like to say that,
Hello.
sir.
Sir,
Is
your
it
slides are
audible, sir?
not moving. Sir, your slides are
Sir,
not
is it
moving.
audible?
Yes, now it is good. Yes.
Is it okay? It is. Yeah, they just wanted to tell the significance of my work. And considering the behavior analysis, because I have to install my control valve into the flow stream in process industries, where I have to measure the fluid flow across the control valve. I have to measure the amount of fluid flowing through the control valve is to be measured. So if I measure the fluid flow into the through the control valve, then I can estimate how much amount of pressure is exerted across the control valve, what is the downstream pressure, what is the upstream pressure, how much amount of losses I encountered. These losses are very significant when I am characterizing the control valve. So that is the reason why we have calculated the head loss coefficient. I will show you. These are all the parameters we estimated. This is the inflow rate of the control valve and outflow rate of the control valve. Across the control valve, the pressure will be developed. The exerted pressure at the upstream pressure of the control valve, this is called UP stands upstream pressure of the control valve, expressed in pounds per square inch. At the downstream pressure of the control valve, we estimated the pressure across between 0 to 100% of the valve opening. This is opening of the control valve in terms of percentage, 0%, 100%, to 0 to 100%. And we also measured certain parameters. That is, so it is abstracting. Sorry. Okay, one second. So this is the parameter. LPH is indicating upstream fluid flow rate and downstream fluid flow rate. And this is the 7.6, 1.52. This is the valve coefficient. This is the flow coefficient. And upstream fluid flow rate and downstream fluid flow rate we calculated. And velocity of the fluid before the control valve and velocity of the fluid after the control, because the valve acts as a restriction in the flow stream. So the velocity of the fluid will be increased at the downstream of the control valve because of this added restriction. There will be a considerable pressure drop at the restriction area where the pressure drop is to be considered. That is the reason why we estimated P1, P2, because if this pressure drop falls below the vapor pressure, the fluid starts boiling, then flashing will be encountered. So there will be a state change of the fluid. Now the fluid is laminar. Now once this turbulence is introduced, the fluid pressure drops below the vapor pressure. It will enter into the boiling state. So the state change from liquid state to the gaseous state, the state change will be changed. So that is the reason why we have to estimate the velocity of the fluid before the control valve and next to the control valve. So that means downstream pressure, that is V2 velocity, and upstream pressure, the velocity is V1. And the head loss coefficient also we have to be considered before we have to calculate the head loss. So that is the reason why all these parameters we considered to estimate the behavior of my control valve opening between 0 to 100%. The problem here is, these are all the experimental readings we achieved, but to analyze them meticulously, we have to analyze the behavior of the control valve. The valve opening is in steps of 10%. But I need to have a 1% valve opening so that I can analyze more insight analysis of the control valve. I can do it. So this is the reason why I applied for interpolation mechanism. The interpolation is essential because initially I applied a coarse interpolation and then I moved towards the dense interpolation. The reason is the valve is opening 0%. In steps of 1%, the valve is opening so that I can apply nonlinear regression models for this one. So because the nonlinear regression models are required to validate my valve behavior. So that is the best fit model I have to be considered. For that, I considered 3 models. One is polynomial regression with a third order polynomial I considered, Gaussian power regression I considered, power law regression models I considered. And these 3 models, why I considered means which model is best fit to determine the coefficient of determination, that is the R-square value, and mean absolute error I considered, root mean square error I considered. And based on these 3 characteristics, which model is best fit? So when I am interpreting these regression models, the polynomial regression model and Gaussian power regression models shows better accuracy, and the error coefficient value is minimum, and this power law regression is showing some underperformance based on my experimental results. So I considered this is the approach I considered. If R-square value within 1, so I got the best fit model, the Gaussian power regression achieved R-square is equal to 1. I will show in my next slide. And polynomial regression is also subsequently correlating to almost similarly responding to the Gaussian process regression, whereas this power law regression is underfit. So, and then I applied AI models for this characterization of the control valve. 2 models I consider random forest and decision tree. Both are the tree model algorithms with I consider 200 escalators for this random forest and decision tree with the density of 6. Density I considered 6 for this random forest, and decision tree for 5 I considered. And for these 2 models also I considered this R-square value, mean absolute error, mean square error value, and all these things. And validation is done with the 5-fold cross validation. K is equal to 5 we considered, and the best fit model curves we considered. We estimated with this random forest and decision tree, and these are the responses we achieved for the outflow of the control valve with the percentage of the valve opening in the x-axis. Y-axis we considered the outflow rate. That is the amount of fluid flowing through the control valve is to be estimated. How much amount of the fluid is discharged at the downstream pressure of the control valve we considered with reference to the valve opening. And the polynomial regression we received the coefficient of determination R-square value is 0.925, and third order polynomial I considered 0.996. Initially we tried with second order polynomial, and then we moved to the third order polynomial. And if I considered the third order polynomial and Gaussian power regression models, the R-square shows 1.00 and polynomial regression shows 0.925, and these 2 are almost close to the 1. But when compared to this third order polynomial and Gaussian power regression, and I received exact best fit model I achieved in the Gaussian power regression model, because this regression model is a goodness of fit and physical trend consistency I achieved. Cross validation stability also achieved with the GPR model and when compared to the power law model. So that is the, see, when I look at this one, there is a nonlinearity exhibits with this. See, this is a blue curve showing polynomial second order. It is almost showing more nonlinearity. It is not tracking my actual data sets. And when compared, see, this is the polynomial third order, it is also showing some nonlinearity between 2 gallons per meter to 2.5 gallons per meter. It's almost exhibiting the nonlinear characteristics. Whereas this power law, this GPR model, Gaussian power regression model C, that is the brown color. This is almost tracking my actual data sets with no deviation, with the coefficient of determination R square is equal to 1. So that is the reason why I consider this is the best fit model for my application to characterize. This is the delta P, that is the differential pressure across the control wall. It needs to be considered because I have to estimate the flow coefficient, fluid flow rate across the control wall. That means the amount of fluid flowing through the control wall is to be estimated. Q is equal to square root of delta P by specific gravity of the fluid. So multiplied with the coefficient, wall coefficient CV. So that is the reason why delta P is to be considered. That is nothing but the differential pressure across the control wall. P2 minus P1 I have to be considered to estimate the flow rate. So polynomial regression is outruled, and here also the Gaussian power regression model and polynomial third order model both shows a very good linearity. In fact, when for this differential pressure calculation, the polynomial with third order is inferior than with the GPR model. GPR model shows very good very good tracking with my data sets. So this is also very supporting to my experimental analysis. So this is the head loss I considered. See the coefficient, the R square value is equal to 1 for this model. For this head loss characteristics also we considered GPR model. See, this is the GPR model is only the tracking, only correlating with my actual data sets, except the remaining, even third order polynomial also deviating between 1.2 to 1.4 head loss coefficient, right? So 95% correlation achieved with the GPR Gaussian power regression models. And these are all the metrics we estimated for the regression models for the respective differential pressure, wall coefficient, head loss. And if I see the power law shows 0.89, 0.88, 0.89, 0.89, all these showing, exhibiting inferior results when compared to the polynomial regression as well as the Gaussian power regression models. This is superior. GPR is exhibiting superior performance over the rest of the polynomial regression and power law regression. But very unfortunately, we can also, this polynomial regression is almost exhibiting similar performance with the GPR model. So that is the best fit model I have to be considered for this regression performance. And then I moved to the, after I estimated,
sorry to interrupt, just wanted to remind you of the time limit here.
Yeah. I'm closing, sir. I'm closing. I'm closing towards them. The performance metrics for the decision tree and random forest I estimated. See, the random forest is showing very good results when compared to the decision tree because the random forest, it averages multiple trees and removing stepwise artifacts and improving smoothness generation. So that is the reason why we achieved the best performance. And cross validation also we considered with the k-fold cross validation with k is equal to 5. And this is a random forest exhibiting the best performance that is shows with the response characteristics. And these are the performance forest as well as the decision tree. And this is the delta P and the wall coefficient and head loss characteristics we considered with the random forest and decision tree algorithms. So we have seen very good response for the predicted analysis, predicted how the model is how the control valve is behaving, that is predicted with the decision tree and random forest, which it shows, it exhibits more linearity across 0 to 100% of the valve opening. And these are all the results for the AI interpretable decision tree and random forest models. The outflow model, see, you have seen R square value. The outflow model, the outflow rate of the control valve is 0.98 for R square and CV 0.98, everything. So when compared to the decision tree and random forest, both random forest shows very good models that is highlighted with yellow color. Because my random forest depth is equal to C6 and
Yes,
estimators I
with
consider
Dr.
200.
Vidyasagar. Yes, Vidyasagar.
Yeah.
Yes, yes.
Please.
So any comparative analysis you have done for the algorithms which you have used?
A comparative algorithm, that means two models I considered. One is the random forest and the decision tree models. Both are random decision tree. I can go for XGBB algorithm. So instead of going for several algorithms, I considered two tree-based algorithms we considered. Two models, random
Okay.
forest is one model and decision tree is another model.
Hyperparameter tuning, have you performed it?
Yeah.
Or any kind of
Optimum tuning,
Z test,
hyperparameters we
T-test?
considered, alpha value considered, and beta value considered. Yeah.
Okay. That's all from my side.
Hyperparameters.
Yes, Dr. Jocelyn.
Yes, good afternoon. My question is this a funded research?
Yeah.
Sir? Yes, to what extent that are you now in a technology transfer or not yet in your community?
Pardon, madam?
Are you now on
Please
technology
come again,
transfer
madam.
in your community? Yes, sir. Okay.
Sir, madam.
It's a funded research, right? My question is,
Yeah.
are you now on the process of transferring this technology to your community or not yet?
No, this is the knowledge we are trying to impart into the industry for improving the performance of the process industries.
Sir, have you deployed
okay.
it? Have you deployed it to the premises from where your project is being funded?
This was conducted in the laboratory, madam.
Okay, so it is not a funded project.
Yeah, it is not it is a real-time work, but the thing is, I already told you. So if the characteristics is to be established, the inherent characteristics and exhibiting characteristics I have to be considered. These parameters we extracted at the inherent characteristics.
Thank you, Vidyasagar. Yes, thank you. Thank you very much.
Thank you.
Yes.
Thank you.
Thank you.
Adesh?
Yes, thank you, sir. Thank you, chairs. Moving towards our last presentation. The paper to be presented is an optimized model for heart attack prediction using SMOTE, Swiss and mini batch gradient descent optimizer. Do we have the authors or co-authors for this paper? Seems not. Just give me a minute here. Yes. So I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and we, on behalf of the whole team, thank you for the support during this version of the conference. We will be happy to have you in the next version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of MCT4SD 2025. I also thank our session chair, Dr. Jocelyn De Vera, for chairing the session. Ma'am, here's a token of appreciation on behalf of Team MCT4SD 2025 and Global Knowledge Research Foundation and partners. Ma'am, I request you to please share your closing remarks with our authors.
Yes, thank you so much. To the organizer of this MCT4SD 2025 and also to all the researcher, I would like to say thank you so much for inviting me as a session chair, especially in this cluster. I enjoyed so much. I enjoyed the listening to your research, and as I mentioned a while ago during my opening, that I am open for collaboration. If in case you wanted to have collaboration, collaborative studies is possible. Again, Sir Adish,
Yes, ma'am.
Dr. Bansha, thank you so
Yes.
much. And to all the researcher, congratulations for your perfect, almost perfect presentation. I love most of your research. Thank you and have a nice.
Thank you, ma'am.
My
I also thank our session chair, Dr. Varsha Jadhav, for chairing the session. And ma'am, here is a token of appreciation on behalf of Team MCT4SD 2025 and Global Knowledge Research Foundation and partners. Ma'am, I also request you to please share your closing remarks with the authors.
Yes, thank you, Adesh. It was really very nice to be a session chair here. More learnings was there, and yes, all of them from various countries. So it is really very nice to learn all through the world. And yes, I thank the international uh, conference chair, Dr. Amit Joshi, and all the team of GR Foundation for inviting me as the session chair. Thank you, Dr. Jocelyn. It was nice meeting you. Hope we'll meet physically sometime. The world is very small. Yes,
Yes, thank
so
you,
it
ma'am.
was,
See you soon.
yes, yes. Yes, and Adesh is my student. So, Adesh, thank you very much. And it was really very nice that you were anchoring such a good conference. What a good confidence. Thank you, Adesh, and congratulations to you also. Thank you
Thank
very
you,
much.
ma'am. So now, thank you once again for your valuable presence to the chairs and the authors. I kindly request you all to switch on the camera for a quick snapshot of the virtual conference. All the authors, it's a request that you please turn on your cameras. Thank you all. Stay safe and take care.
Yes, Adesh, please share the photos.
Sure, ma'am.
Yes, thank you.
Thank you. Goodbye. Have a great night.
Thank you, Adesh garu.
Thank you, sir.
Thank you.
Thank you, Sir Adi.
Thank you, ma'am.